If all goes well, you'll receive a package like this. On opening, the first page is the manual, with video links, download links, and some notes you should read in advance. Inside are all the parts except the 3D printed ones, each labeled. Some parts include spares, so don't worry if you have leftovers after assembly. Scan the QR code to open the download link for the print files. It's recommended to start printing after you receive the package. Among all the parts, the gears must be printed with PLA plus EF or other stiffer engineering materials, especially the two beveled gears. The 3D print files are already laid out on the build plate and can be printed directly. Be extra careful when removing the supports on the base, especially at these two spots. Since this is a slide rail structure, use a scraper to separate and then pull them out. Forcing them off by hand can easily break them. Other supports can be removed as usual. Printing all the parts will take about 2 days in total. Now start installing the display module. Pay attention to the orientation. The 4-pin socket should face the opening. Install and tighten the mounting screws. Insert the 4-pin ribbon cable. Put on the cover. Tighten the screws, and the display module is installed. Install the filament runout sensor module. There will be many M3 nut slots later. Press the nuts in with a larger screwdriver. If they go in crooked or fall in, use a small screwdriver to gently correct them. Watch the mounting direction of the limit switch. This also matches the direction the wire will enter later. Add the screws, but don't tighten them yet. First install the ceramic guide eye, then tighten everything. Use PB2 310 self-tapping screws to secure the limit switch. All limit switches later will use this same type of screw. Feed in some filament and test the state of the limit switch. Install the Z-axis pivot head. Same as before, whenever you see a hex shape, you can embed an M3 nut. Insert the guide tube all the way to the bottom. You can gently flex the opening to help push it in. Insert the ceramic guide eye. Tighten the screws to secure it. Use PM320 screws to connect the parts. This is a moving joint, so do not fully tighten the screw. It should be able to swing freely. Use the clip to connect the timing belt. Fix it with PB2 310 self-tapping screws. This part is now installed. Next, install the Z-axis module. As usual, press in the nuts first. Place the timing belt pulley. Install the gear with the side that has the clip facing outward. Place the previously assembled part on top. Add a washer. Before closing it completely, first sort and tuck in the limit switch wires. You won't be able to adjust them after closing. Insert the bushing. Close the front and back halves in the order: washer, bushing, washer. Secure the front and back of the Z-axis module. Turn the timing belt by hand. The resistance should be a bit heavy, but it should still move back and forth smoothly. Install and fix the limit switch here. Install the stepper motor. Insert it and then fasten it with screws. Finally, tidy up the cables. At this point, the Z-axis module assembly is complete. Next, install the slider onto the Z-axis module. As usual, press in the M3 nuts first. In this new version, bushings will no longer be added. Using a smooth round shaft directly provides a smoother sliding motion. Press in the lead screw nut. Use PM310 screws to secure the lead screw nut. When tightening, try to keep it as level as possible to avoid tilting the lead screw nut. Use PM320 screws to connect the Z-axis module and the slider. The Z-axis slider is now connected. Now assemble the sliding swing arms. Press the detent ball into the inside of the slider. Place the circlip in the center recess. Adjust the position so the circlip is vertical to the base. This will make later assembly easier. Tighten the fixing screw. Once it's tight, the arm can't be rotated. To adjust the arm later, you must loosen this screw first. Repeat the same steps to install all four. Install the supply spool damper. Insert the screw. Press it in at this angle. This part provides friction. It will gradually wear down over long use and can be replaced as needed. Install bushings for the winding shaft. Install the winding shaft motor. Refer to the diagram for the swing arm orientation and start securing the swing arms. Find the connector piece. Tap in the square steel rod, keeping the swing arm and base aligned as shown in the video. Use a spacer, then lightly tap until it protrudes slightly. Tap in the other two in the same way. Take out the springs and start installing the sliding swing arms. Place the springs into the raised slots on both sides. Hold the spring by hand, align the square hole, then tap it in. Loosen the screw slightly. Pressing the spring now lets you rotate the arm. Tap the last one into place as well. All swing arms are now installed. Now start installing the X-axis. First, install the control panel. Install the two illuminated buttons. S or B is the blue button and R is the red button. The blue button goes on the left, the red one on the right. Each ribbon cable has a unique connector, so you don't need to worry about plugging them into the wrong place. This is the X-axis rail. Embed the nuts inside the gear. The gear connects to the flanged bearing, which then mates with the lead screw. When installing the lead screw, be sure to tighten the screws on both sides evenly at the same time. Don't fully tighten one side first and then the other. Install the X-axis motor. When installing, make sure not to press the encoder ring all the way down so it jams at the bottom. Secure the motor with PM310 screws. Embed M3 nuts on both sides. Note, this is the only nut whose insertion angle is different. Once installed, it should sit flush with the bottom surface without protruding. Install the X-axis limit switch. Make sure the limit switch opening faces the side. Install the smooth rod. Place the Z-axis module in position and slide in the smooth rods. Test the sliding motion. Finally, screw in the lead screw. Align the gear with the motor output shaft and press them into place together. Gently twist the gear to test the transmission. Organize the ribbon cables for the control panel. Press it into place along the slide rail, taking care not to pinch any cables. Install the back cover for the gears. Use PM320 screws here. Important, do not fully tighten these to screws. Just snug them lightly, otherwise the X-axis motor may jam. The X-axis installation is complete. Now start the final assembly. Pre-install M3 nuts in all available nut slots. If a nut goes in crooked, use a small screwdriver to gently twist it into alignment. Install the X-axis module first. These are the cable pass-through holes for the front control panel and its limit switch. These two holes connect the X-axis to the base. When fastening, be careful not to pinch or break the ribbon cables underneath. Mount the swing arms onto the base. As before, insert the springs. Use screws to secure the swing arms. Install the bevel gears. Embed the fixing nuts. Insert the screws, but don't tighten them yet. Fit the motor output shaft into the bevel gear. Now tighten the screws. Start installing the winding shaft. Use a washer to space the swing arm away from the bevel gear. The D-shaped shaft should sit flush with the bevel gear. Insert the sliding swing arm. These are the cable pass-through holes for the Z-axis stepper motor and its limit switch. These are the pass-through holes for the Y-axis winding shaft motor and the side limit switch. This is the winding shaft encoder motor connector. This is the X-axis encoder motor connector. Organize the cables at the front. Install the cable cover. Install the filament runout sensor. Choose one of the longer white zip ties. Just lightly fasten the zip tie for now. You can tighten it gradually later. This is the pass-through hole for the runout sensor cable. Again, only lightly fasten the zip tie so it can be adjusted later. Pay attention to the limit switch orientation to avoid installing it backwards. Secure the runout sensor module. After installation, set its height to 70 millimeters. This is very important, as it directly affects how smoothly the filament exits. Install the control board. First, fasten the board with screws. The functions of each connector on the board are shown in the diagram. Limit switches, buttons, stepper motors, encoder motors, and the display each have their own dedicated connectors. So you don't need to worry about plugging into the wrong type. Just carefully match each plug to the right connector of the same type. The boxed area shows the output headers for the limit switches. Connect them according to the labels. Find the blue button's LED cable and plug it into the top connector. You can also power on and plug in just one cable to identify its color. These are the motor connectors. The board also has labels to help you match them. Finally, connect the display. Flip the unit over and test that it powers on properly. Test each limit switch, checking that it opens and closes correctly. On the first power up, you'll also need to run a calibration. Once everything checks out, use zip ties to tidy up the cable bundles. Use PB310 self-tapping screws to fasten the bottom cover. Finally, start installing the winding spool. Press M3 nuts into the screw positions. Install the M8 nut on the back. Install the M8 AD long screw. Assemble the spool pieces one by one according to the diagram. Test the clamping effect. The conical design lets the spool automatically adapt to different hub diameters. Place it onto the swing arm and it's ready for normal use. Insert the spool clamp into the D-shaped shaft. Tighten the fixing screw. Before first use, it's recommended to let the gears run in for a while. Choose a preset that you don't currently need. Turn off filament runout detection. Set X-axis offset to 0 and set the travel distance to the maximum. Also set the speed to maximum. Start the run-in. At first, the speed will be a bit slow, around 140 revolutions per minute. After continuous operation for about 2,000 revolutions, the backlash and gear meshing will gradually improve, and the speed can reach around 180 revolutions per minute. Alright, at this point the machine assembly is complete. If you have any other questions, feel free to contact me anytime.